I'm here with Mr. Wagner. So Mr. Wagner, I hear it's that time of year again for your physics kids to make bridges. So can you tell me a little bit about the project?
Yeah, so we've been designing our truss bridges and we're using balsa wood again this year. We've revitalized the way we're going to test it with our testing device, but this year we've also been talking about the math that goes into calculating truss bridges. So we've been discussing the trig that goes with that and trying to calculate how much weight these bridges might hold, which your guess is as good as mine at this point. So we'll see what we can hold.
So I've heard that the bridge project's kind of revitalized, like you said, this year. What are some new constraints?
Yeah, so we gave them less material this year, but also we gave them smaller pieces so they can't use as big of a beam as they did in the past. But also we found there was a problem with the testing device that kind of skewed the results, and we want to have a good assessment this year that everybody's treated fairly.
It's still going. Wow.
It's still going. You see it starting to sag at the top beam.
Okay. Yeah, that's going.
Yeah.
Oh. Whoa!
Did you notice about this bridge? What was the benefit of it? Why it took so long to fail? Did you notice it? Nope. The way the weight bar was positioned, it was right on these slats. So those slats had to physically bend enough before the bridge would fail. So as I'm looking at this, it had to be a clean break of the entire deck of the bridge. It was not the trusses. Typically when we do this, a lot of times the struts and the trusses are the things that fail, one of the beams. In this case, it was the physical deck because this was made so tough. These deck plates had to fail first. So in a way, it was kind of like the problem we had last year, but it was good because
of the metal.
it was not because of me, it was because you made a stronger bridge. So good job. All right, next victim.
Stay steady. Stay steady.
Please stop. There you go. Please. Oh, I need to see
Still intact.
that. Oh, no, it's not.
No, we definitely.
You see, look at where it broke through the deck. See that? Now you did have a sag, a beam broke up here too, but it broke through the deck. You know what I mean? It broke before your weld. They say that your weld should break before the beam, or the beam should break before the weld, right? You tack this stuff on with hot glue. That part stayed. These three beams broke. This part stayed. That broke. This beam broke. Here, maybe, I don't know, did you have ones that were glued? No, you didn't. Okay, so your glue was stronger than the physical beam, so you glued well. Yeah. So
Good job, guys.
because look at this, every single break except for this one, this is the only break that happened, and it was just because of where the deck plate was and the plate. So if you guys are going into engineering and you go into structural analysis or work for the NTSB, your job would literally be to look at stuff like this and determine part failure. Why did the plane crash? Why did the bridge fall down? So you do a structural analysis and you see, okay, well, it wasn't the weld, it wasn't the bolts that were holding it in. The physical beam was not strong enough to support that weight. It's settling. It is for now preventing the collapse.
It's about it. You can hear it.
It is separated.
So Mr. Wagner, I hear your physics class just completed their annual bridge project. Can you tell me about the results?
Yeah, so we had 3 bridges that we tested, and all of them held at least 35 pounds of sand. Some of them did better than others, but I was happy to say that all of the bridges failed because of the balsa wood breaking, not a mistake that any of them made.
Alrighty, that sounds good. Thank you. I'm here with Chris. So Chris, your bridge came in second place and held how much weight?
45 pounds.
And so how did you go into designing this bridge?
Well, it was a group effort, obviously, but honestly, we just put as many triangles as we could, and it ended up working out, and then we just put a bunch of glue.
All right, that sounds good. Thank you. Good job.
Thank you.